In this video and short presentation, we talk about pressure testing large jobs. So when you pressure test a standard residential system, we've talked about that a lot, but what happens when you've got a lot of copper lines and you need to make 100% sure that none of them are leaking? In this video, we talk a little bit about that. I also want to add, we didn't really talk a lot about the temperature compensation side of things, and I always suggest when you pressurize something to log that temperature and then to look at the temperature again when you come back, and we have a calculator for that in the HVAC School app that'll make that easy for you. But anyway, big thanks to Matthew Taylor for giving this class. I think you'll get a lot out of it.
First thing I want to talk about is now that we've done all this brazing, right? We got all of our stuff done. What are we going to do next? We're going to pressure test it. We're going to make sure we don't have a leak. All right. These large commercial systems, supermarkets, we got a lot of joints. All right. So there's a definite possibility we've left a leak somewhere. We want to know that. So we're going to do that using our nitrogen that's free, grows on trees, right? All right. So we're going to use the nitrogen to do that. In all seriousness, there's a couple reasons why we're going to use nitrogen. Nitrogen it doesn't change pressure with temperature very much in the range we work. It does, you know, technically, but pretty minor, right? It's very inexpensive. We can pressurize the entire system and check all the little places we can't get to with a leak detector, underground, overhead, inside the Armaflex, all those places. We can check all that at one time, right? So nitrogen is really, really useful for pressure testing. So we're going to talk about how to do that. One thing Nathan talked about is being very careful about a pressurized system that has refrigerant and adding nitrogen pressure, right? We're never going to do a pressure test with nitrogen on a system that is connected to a refrigerant system. We're not going to count on a ball valve or a service valve or anything like that to separate those two. We just can't trust that, okay? When we're purging and we're flowing because we're soldering, we're at much lower pressures than we're talking about for a pressure test. So if we're going to pressure test, and there is, you know, we're pressure testing some circuits, for instance, on a rack. We're gonna physically cut those pipes and separate them from the rack, right? We're never going to add pressure at this level to a live system that has refrigerant on the other side. So that's one of the key pieces there. All right. So when we're thinking about this using our brain, right? We could have some very different environments where we're doing this. One may be a brand new store that there's no product in. It's not open. We're building it. Doesn't even have refrigerant charged yet. Well, that's an environment where we can leave that pressure on for a very long time and be very sure that we have no leaks, right? On the service side, we've got a whole nother animal, right? Real common problem, frozen food doors. We got underground pipes that go out there to those circuits. Leak detectors kind of going off near the pit. We think maybe one of those 6 pipes is leaking, don't know which one. Right? This is a real problem, okay? We can use nitrogen to pressure test, isolate those pipes, get them off the rack, pump them up, and do a much faster test that will show us which one of those pipes is our problem, right? So just 2 different ways to do that, 2 completely different applications in the install world and in the service side. We'll just combine those ideas as the real world problems come up. So how do we do this? Well, once again, I'm going to go through all the steps, but the idea here is we're going to add a manifold set, some type of gauge that we're going to leave on the system. All right. We like to use electronics these days. They're pretty cool. In this application, we may want to go old school and use an analog gauge. The reason, because we're going to leave this thing on there at least 24 hours, sometimes a month, right? We don't want to worry about losing our calibration. We don't want to worry about who's got the right app to read the thing. We don't want, you know, we want a nice gauge. We can probably grease pencil that gauge and come back in a month, and if that thing has moved, we know we got a leak, right? So the other thing about this type of pressure test versus our electronics are going to be very, very accurate. They're going to show us tenths of a PSI. We really don't need to be that extreme with this. If we're within 2 or 3 pounds, we don't have a leak. If this thing is leaking, we're going to lose 100 pounds. We're going to, it's going to be pretty dramatic. So that analog gauge just tends to work a little better in that application.
I want to make a quick distinction, though, which is that There's a big difference between a new store, a lot of pipe, you're leaving it on for a long time, versus if you're there for a service repair, and you still need to make sure everything's not leaking. That's where a digital comes in really handy, because now you may only have an hour to do a pressure test, and so watching for that 1/10 or 2/10 of a PSI drop, and using soap bubbles if you're the one who made the connection. And so this is where application is so key. Sorry to interrupt.
Yep. And you just brought up the next piece I was going to talk about, and that's soap bubbles, right? Yeah. Right. So once we get this thing up to pressure, now is a perfect time to use our soap bubbles. The nitrogen is actually slightly smaller molecule, may leak a little better than our regular refrigerants. It will definitely cause bubbles, right? So this is the time we're going to hit all of our joints with our bubbles before we start that vacuum process and everything else. And as he said, if it's a small system particularly, we will see that change in pressure very quickly. We'll see that fall out. On our very large systems with Armaflex and whatnot, it may not be practical, right, to soap all of our joints. So we will soap the ones we can get to. All right. Then we're going to close off the system and we're going to give it its time. Okay. Go ahead. So the time that we do that, we've already kind of touched on. Really, the longer, the better. The most practical timeline that we can go, the more obvious our leak is going to be. I mean, it's just that simple. So if we're driving it down to an hour, we're going to see a very small change. If we're leaving it for 30 days, and we've got a leak, it's going to be very obvious long before 30 days. We're going to notice that right away. So just know that once again, the circumstance is going to determine how long we actually leave this thing sitting for. And there's our bubbles, right? There we go. I'm going to go ahead and pressurize a nitrogen rig and talk about that for a minute. So on my nitrogen rig, I might find it useful, once again, to use a core tool instead of my manifold set. It's not as critical this time, but it's a good practice because, once again, I've got one sealed valve instead of a 4-port manifold. I've got all kinds of gaskets and valves and shutoffs and anti-leak fittings and all that stuff that could be a potential problem, right? Well, in the end, what I want to do is leave this system, as we talked about. 30 days is not uncommon, right? 2 weeks, right? So I don't want to leave my manifold set hanging either. I want to leave a system that is compact and can take care of itself, so to speak. That's why I brought that gauge up. All right, this particular one, there's nothing special about it. In fact, it's a discharge gauge right off a manifold. I mean, there literally is nothing special about it. It just has a short piece instead of a tube, a hose, right? You notice it's not sitting at 0. Okay, it's out of calibration, right? So why am I using this, right? Because it really doesn't matter. That's my point, okay? I'm going to leave this attached to my system. I'm going to pressurize this until it reads something. I don't even care what, right? As long as it's in my range, I'm going to mark that pressure, write it on the pipe, and when I come back 30 days from now, it better be at the same place. Even if it's out of calibration, it doesn't matter. I just don't want it to move, right? Does that make sense? Now, when we talk about, I did mention that temperature does affect pressure for nitrogen. This could be a whole hour-long class. Not going to get into that. But just know that that here in Florida, particularly where we don't have these wild temperature swings, it's not going to minus 30 and then 70 in the afternoon, right? It's just not doing that. We're going to have maybe 20, 30 degree swing, 2 to 3 PSI max is what we're going to actually see in our outside conditions here. It's very minor. When I say it's minor, it's very 2-3 pounds. That's it, right? If I see a 50-pound drop, a 25-pound drop, that's what a leak is going to look like. Don't attribute that to the temperature because it's 70 degrees and it was 90 when I hooked this thing up. It ain't that, okay? One of the routines that we do is 24 hours, right? Or 7 days. Well, we tend to end that 24 hours at the same time of day as we started it, right? So if it was 90 degrees at 2 o'clock in the afternoon, it's probably gonna be pretty close to 90 degrees, 2 o'clock in the afternoon the next day, right? So I'm gonna have very little temperature difference. That's another thing to remember. Now, if I'm holding this thing for 30 days, who knows? I may turn this thing on in the middle of the night and I come, day 30.5, right? I'm there the next morning. Might be different. But most of the time for the service work we're doing, it's going to be a very similar time of day that we're going to be checking that, and there's going to be negligible effect. Okay, so we talked about they're setting up purging and all that over there. I've got those markings on my regulator. I'm not going to pay any attention to that today because we're just pressurizing, right? So I'm going to turn on my pressure, and I'm going to set my regulator to about the pressure that I want. Now, what pressure do I want? Depends on what I'm pressurizing and what it's rated to, okay? Condensers, typically good to 450, 500 pounds, right? But my evaporators, not so much. Maybe 150. We got to be careful on the evaporators. Often 250 is a standard, okay? So I'm going to set my gauge to that pressure, whatever that maximum is that it can be allowed, okay? Now, once my gauge is dialed in, I'm going to flow that into my pipe system, and I'm going to see this gauge rise. Now, what I was talking about earlier, I don't know that I can trust that gauge, right? I mean, that one's a little bit out of calibration. I don't really care. As long as my gauge is pretty close over here, it doesn't have to be 450. It can be 437. That's okay, right? What I'm looking for is a reference. I want to see it. I don't want to see a change, right? Whatever that gauge is showing me when I do that, okay? All right, so we're going to go ahead and open that up. Okay, and I've got my pressures coming up. I set my gauge over here at about 4 1/4, and it looks like it's coming up to around 450. So they don't really agree, okay? Is that okay? Yeah, that's fine. That's gonna give me my pressure test. Now, if I've got a specific target that I have to hit for a customer, they wanna see 250, right? Then I'm probably gonna use an electronic gauge also on another service port and dial that in precisely, right? But if I'm just doing my own pressure test and I want to run this somewhere around 450, I'm now at 445, all right, I'm going to call that pretty good. I'm going to isolate this guy after I do my leak check, right? So while I've got it pressurized before I isolate, I may have a leak, right? This is my first pressure test after I've done all of my soldering. So if I've got a leak, now is when I'm going to find it, right now. So every fitting that is accessible, I'm going to go ahead and soap bubble up. All right, and I'm going to include my fittings because I could have a leak there, right? Now, these, as I was describing earlier, will absolutely bubble up. At least as well as your refrigerant, probably even better. You're going to get bubbles if you've got a leak. All right, so I passed my leak check. Now I'm going to isolate. All right, now that I've isolated, I'm going to begin that check, okay? So when I do that, we talked about it, I'm going to mark this somehow. We can record this any way you want, but the way that I recommend is that you record it on the pipe near the gauge, okay? Why? Because that's where whoever's going to check is going to check. May not be you, may be you, you may not remember, but you're going to see the gauge and you're going to see that pressure. Put your tape very close to the gauge so that standing there you can see what's going on. All right, this guy is sitting here at 440 PSI. You're going to put the date and the time, and I'm probably going to put my initials on there and the temperature. 84. I'm going to isolate my nitrogen. And I'm going to take it off, okay, because I don't need it. I can move this whole system now to something else, right? My nitrogen's free, the system's under pressure, and it's going to see in a month, right? Let's be realistic, I'm coming back tomorrow. If I've got a leak, I'm going to see that very dramatically, very quickly, okay? That's when I'm going to stop, go find my leak, repair it, start it again.